Hello, in this video I will show you how to solve all problems in the practice test 1 calculus 2. Okay, so let's start with the first question. Find the area of the given region. Usually when you see an area problem, the first step we need to do is to figure it out about the graph of the function, if the graph is above or under x-axis. In this situation, our graph is above x-axis, and that is given, so it's very easy. So by the definition of definite integrals, you can see the area of this guy is just equal to the definite integral from 0 to 4, right? 6 dx over 16 plus x squared. And this is equal to 6 integral from 0 to 4 dx over 4 squared plus x squared. I write 4 squared plus x squared because we have some formula for that. So you write that is 6, and then you apply this for a tangent, right? You can check in the formula sheet, right? That is 1 over a arctangent of x over a, which is x over 4, right? And this evaluated from 0 to 4. So you just need to plug 4 and 0 into x. Then this is equal to 3 over 2 because 6 over 4 is 3 over 2. Arctangent of 4 over 4 minus arctangent of 0 over 4. So you can write, you can use calculator or you can use the unit circle to see the value of this guy. Just 4 over 4 is 1, a tangent of 1 is just pi over 4, and a tangent of 0 is 0. So that's why you have 3 pi over 8. So this is the first problem. Let's move to the second one. Evaluate the definite integral. Alright, so in the previous problem, you have integral of the form dx over a squared plus x squared. So this is about arctangent, right? In this integral, you have another form. This guy of dx integral dx guy of u, let's say a squared minus u squared. So that would remind you about arc sine of u, right? Something like that. U of a, let's say that, plus c. So we try to get the form like this, and then we evaluate the indefinite integral. I prefer to find indefinite integral first, and then I plug integral limits in here into the last formula. So let's do that. Since I have 25x in here, I would do substitution. U equal to 5x. Why? Because u squared is 25x. Because u squared is 25x squared. So that's why I do this substitution. After this, I have to find integral du right away. I find du as 5 dx, right? And so we can solve for dx, that is just du over 5. And now I have to rewrite our original integral in terms of u. So if we rewrite this, we have the following one. I will ignore integration limits in here, okay? I just write indefinite integral. Dx is du over 5, and then we have square root of 1 minus u squared. So that is 1/5 du over 1 minus u squared. And you can check the formula sheet. That is nothing but 1/5, and then arc sine of u plus c. Actually, for such problem, I don't have to write c because After that, we have to evaluate, right? Definite integral. But anyway, let's do that. And then from now, I have to plug, the substitution back here. So I have 1/5 xi of 5x plus c. And now we can plug integration limits into the last formula. So our definite integral is equal to 1/5 xi of 5 times 1/5 minus xi of 5 times 0. So, this guy just 1, this guy is 0, and xi of 1 is pi over 2. So the answer is 1/5 pi over 2. Xi of 0 is 0. The final answer is pi over 10. All right, let's move to the next problem. In this problem, they ask us to find the indefinite integral. Okay, so you see, we have kind of, square root of 1 minus x to the 4, right? And here on the top, you have combination x and then dx. If you see that combination, it is likely that we need to do substitution u equal to x squared. Why? Because if we put u equal to x squared, from here we get du is 2x dx. So you already have the combination x dx in here. Okay, that is very useful. So you have du over 2. And now we can rewrite our integral in terms of u. So this integral is equal to x dx is du over 2. So I write du over 2 in here, and then square root of 1 minus x4. U is equal to x squared. That means u squared is equal to x to the 4, right? So here's I have u 1 minus u squared. And we already go back to the previous integral. So that is 1/2 du over 1 minus u squared. And that is 1/2 xi of u plus c. And then now we plug the substitution back here. So means we plug this guy back here. We get the final answer 1/2. And then xi of u is x squared. And then I don't need to write this. And then plus c. Done. Okay, let's move to the next page. Here they ask us to find derivative. So in this chapter we learn logarithmic function, exponential function, inverse functions, right? And differentiation, integration involving such functions. So we need to memorize the formula. Otherwise, or in case if we don't remember that, please have a formula sheet with you. So let's discuss about this problem, right? Here you have two functions. The first function is arc cosequence. The second function, the inside function, is 2x squared. Means we have to use the chain rule in this case, right? Let me remind you about the chain rule. The chain rule says if you want to differentiate f of gx, so you have to differentiate the outside function first, right? And then you evaluate at the inside, and then multiply with the derivative of the inside. So for this guy, f is a cosequence, right? And then g is 2x squared. So we know 2x squared, let's say your derivative of this guy is equal to xi secant derivative. What's that? So xi secant derivative, let me remind you somewhere in here. I write here xi cosequence of u derivative equal to negative u prime over absolute of u, and then u squared minus 1. So you just apply this formula, right? In this case, u is equal to 2x squared. So you have negative 2x squared prime, that is negative 4x over absolute of 2x squared, which is u. And then here you have 2x squared, everything square, and then minus 1. That's it. So if you have formula sheet with you, you can solve this problem in, let's say, 1 minute. All right, let's move to the next one. Evaluate each expression without using calculator. Of course, with calculator, everything is easy, right? So you just put your function in calculator, and then it will show you the answer. All right, so here we have psi and arcsine. Psi and arcsine. For inverse function, we have the following identity. F of f to negative 1x equal to x. And f to negative 1 fx equal to x. So it's obvious that sine and arcsine are inverse, right, of each other. So this is just 1/2. Because you apply sine to its inverse. So you get, just x in here, right? Next problem is a little bit more complicated, but that is not much difficult. Let's say now you have psi, right? Arcsine 1/2, and they ask you to find cosine. So let's see, what's that, right? Here's the unit circle. Arcsine equal to 1/2. How to find that? So if I have 1/2 in here, I just take make a horizontal line, and that is my arcsine 1/2. And then they ask us to find cosine of arcsine 1/2, means this value. That is what we need to find. Cosine of arcsine 1/2. Okay. Of course, we can ask this guy is just pi over 6, and then cosine pi over 6 is that is cosine pi over 6, which is quarter 3 over 2. But let's solve that, right, in another way. So for such a problem, I will put x equal to arcsine of 1 over 2. So suppose that I don't know this value. I don't know. I just say, yeah, that is just x, right? Then this is equivalent to that sine of x is 1 over 2. So it turns out that they give us sine of x, and they ask us to find cosine of, since we already put this guy equal to x, right? So we need to find cosine of x. That's it. So we know now we use the identity between sine and cosine. We know that cosine square of x plus sine square of x is 1. From here, I get cosine square of x is 1 minus sine square of x. And then we can plug 1/2 in here. We get 1 minus 1/2 square. And that is 3/4, right? So cosine square is 3/4. And now you apply square root, you get cosine of x equal to plus minus square root of 3 over 2. I mentioned plus minus because, we don't know if cosine is positive or negative. So when we apply square root to square, we need to have plus and minus. But in our situation, cosine is positive, because, x is positive, right? No, it's about sine of x is 1/2. And we consider the inverse between, the angle between negative pi over 2 to pi over 2. So for all these angles, cosine should be positive. From here, I get cosine of x is just equal to square root 3 over 2. So you can see this is matched with this. Perfect. Now let's move to the next one. In this chapter, we also learn Lobster rule, right? And when we study Lobster rule, I explain a lot, different kinds of limits that can be used that can be solved with the Lobster rule. I also teach to you the comparison between logarithmic functions, power functions of polynomials, and exponential functions. So now we can use Lobster rule in this problem, but I would like to use that comparison. Okay, so you also can use that in the test. Uh, let's say this form, the first thing when you see a limit, you plug that number into the limit, right? So informally, this limit has the form infinity to 0, because x approaches infinity, ln goes to infinity, and 8 over x goes to 0. We have another forms like infinity over 1, like infinity 0 to infinity, 1 to infinity, and so on, right? For such integral, we have a general instruction. So I suppose that the limit is x. I put that is a, right? A equal to the limit of this guy. And apply ln of a. I apply ln to both sides. So I have the following one. ln of x, and then, a to the x goes to infinity. We can bring ln into limit because ln is continuous function. So for continuous function, everything's good. We can bring the limit in or out, okay? So once we have this, we can bring, the power here, a to the x, down here, okay? So we have the following. This guy is just equal to limit of x goes to infinity, and then 8 over x, ln of x. Or I can rewrite it in the following form. Limit of this guy x goes to infinity, and in the fractional form, ln x over, okay, 8 in here and over x. A is just a number, we can print it out. And now, of course, you can use L'Hopital rule, right? Because this limit has the form infinity over infinity. You can differentiate the top and differentiate the bottom. And then, differentiate until you get a limit. But since we already learned about comparison, right, between ln, right, let me write that, ln of x is very small if you compare with the x at infinity, and x is very small if you compare with e to the x. So based on this comparison, you can do conclusion. The limit is equal to 0, because on the top you have ln of x, ln of x. So ln of x is even, smaller than ln of x at infinity. So, you have this, and then since that guy is very small, if you compare with the x, the limit is just 0, because x approaches infinity faster than ln. Finally, we got ln of a, right? ln of a is in here, equal to 0 in here. So let me rewrite that. ln of a equal to 0. From here I get a is equal to e to 0, which is just 1. And that is the final answer. All right. Okay, let's move to the next page. This problem is pretty easy. I just want to warn you to, remember how to get a graph, graph of a new function from old functions, right? So in here, they ask you to see the graph of this guy, ln of x plus 1, right? So you have, you can guess ln x plus 1, comes just very similar to ln of x, right? You can obtain the graph of ln of x plus 1 from the graph of ln of x by shipping the graph of ln of x to the left. Why? Because here you have x plus 1. If you have x minus 1, probably you would shift the graph of ln of x to the right on 1 unit, right? But in this situation, you have just x plus 1. So based on that observation, we do the following conclusion. This is a correct one. Why? Because the graph of ln looks like this, right? Looks like this. And then you shift this to the left. So you go, from 0 here to the left and here. The second graph is not correct because, we don't shift anything. We just, make some scale, some change in the graph. And then the third one is also not correct. The last one is the graph of ln of x minus 1, because we shift the graph, of ln of x, to the right. Okay, let's move to the next problem. In this problem, in 1, 2, 3, 4, 4 problems in here, we use properties of ln. Ln has very good problem. We actually apply that when we study limit, of the form infinity to 0. We just solved that. Here, we can use ln to, differentiate, complex functions, right? And how to do that? So in this problem, they ask you to just expand the logarithmic expression. So here is a common principle. If you have power like power here, this is power 1/5, right? You bring the power out of ln. Everything on the top of the fraction will be with positive side. Everything in the bottom of the fraction will go with negative side. So that is common principle, and based on that you can write very fast ln of square fifth root. So you write 1/5, okay, and then ln of 9x squared minus 1, because 9x squared minus 1 is on the top, right? And then you have ln of 9x squared plus 1 in here, but with the negative side, because that is in the bottom. Done. So that is your answer. Basically, if you remember this property, this principle, you can solve this problem in 30 seconds. Similarly, you can solve the next problem. Okay, so they ask you to write in a single logarithmic function, right? So again, here you have positive 4. That means 4 is on the top. If you have 1/4, that means 1/4 is the power. So you have to bring 1/4 right here, right? And the sign here is plus, means this term is also on the top. For the x, you have negative. That means x in the bottom. Okay, so this is equal to ln. On the top, I will have 4. And then 4 minus x squared, but with the power 1/4. You see? The power in here. And then x in here. Done. All right. Okay, let's move to the next one. Find the derivative of the function. So for such problem, again, we need to memorize, basic differentiation rules. Like in this case, we have product of two functions, right? People are confused when they need to confuse how to choose a correct rule. But for example, they always intend to use, for example, chain rule, and they try to use the chain rule. But this is product. I don't care about square root of ln of x at the beginning, because I just care about the product of x and that guy. So we need to use the product rule first, and then we'll see what happened during that. Okay, so I use the product rule. The product rule say uv prime is u prime v plus uv prime. I write from here f derivative equal to x derivative is 1. So let me write f derivative, and then ln of x plus x. ln of x, I write 1/2. How about that? Derivative. Because square root is power 1/2. Okay, so derivative of x is just 1. So the first term is just ln of x square root, right? And the second term, I need to differentiate this function. I will calculate that, separately, okay? I write here. I will apply the chain rule. The chain rule, first I apply the power rule, because the power is outside function, right? 1/2. For the power rule, I have to reduce the power by 1, right? And then I just copy ln of x in here. And then multiply with the derivative of ln of x, which is 1/x. That's it. And then, we can simplify, for example, we can simplify x in here with the x in here. So x will be cancelled out. And here is power -1/2. With power -1/2, we can right, like we flip that, we get, 1 over, okay, something in here. But I will leave that for you. Again, we need to find the derivative of this function, and of course we, for such problem you can use the chain rule, because you have three functions in here, right? Ln, and then square root, and then quotient in here. But if we use properties of Ln, we can expand this into smaller expressions, like this is equal to, here's the power 1 over 2, like previous example. I can write just 1 over 2 in here. Ln of x squared plus 4, right? And then minus ln of x squared minus 4. Because x squared plus 4 is on the top, right? Everything on the top will be with positive side. Everything in the bottom will be with negative side. So that's why I have this. And now we can differentiate this. We get 1 over 2. And for this term, we use the chain rule, right? Ln u prime is u prime over u. So in this case, u is x squared plus 4. U prime is just 2x. So I write 2x right away. And then here, x squared plus 4. Similarly, I have 2x in here, and then x squared minus 4. You can simplify 2 with 2, right? But, you do that yourself, okay? Let's move to the next one, find the indefinite integral. So for this problem, let's do some observation, right? So in the top, in the bottom, you have x cubed plus 1, and on the top you have x squared dx. So probably you can guess, since the power on the top is 2, which is less than 1, right? Less than the power in the bottom on 1 unit. So you put u equal to x cubed plus 1. Because if you do this substitution, when you differentiate that, you get 3 x squared dx. So you get this combination, on the top. That is very good. And then I can rewrite our original integral like x squared dx is du over 3. So I write here du over 3, okay? And then all this thing is just u, you see? And this is 1/3 ln of u, absolute of u plus c. And that is nothing but 1/3 ln of x cubed plus 1 plus c. So I think such problem is pretty easy enough. Okay, let's move to the next one. Find the indefinite integral. So we have fraction, right? We have fraction function inside the integral. We might think about, simplify the integrand function first. So it means we have to take x squared minus 4x plus 1 and divide by x squared plus 1 in here. Let's do that. But for this function, it's very obvious that you have x squared on the top and then 1 on the top, right? So it means if you just compare x squared and 1, right? And then you have x squared and 1 in here, everything should be simpler. So let me break this integral into two integrals. I write this is equal to integral of x squared plus 1 over x squared plus 1 dx, and then minus 4 x dx over x squared plus 1. You see, I just got x squared and 1 together, right? And another term is negative 4x in here. So I break it in a new integral. It's just negative 4x dx. For this guy, that's just 1, just dx, right? For the second guy, I can tell you, we have this very special form. Why? Because on the top, you have combination x dx. And here you have x squared plus 1 or something like that in the bottom. So if you remember, we saw one problem right in this video. We put u equal to x squared plus 1. And we, differentiate that, you get du is just 2x dx. Everything looks good, right? So I will leave this problem for you to finish, okay? Try to do that for yourself. Let's move to the next one. Evaluate the definite integral. Okay, so it looks uncommon, right, when you have ln of x in your integral. But here's the principle. In our course, if you see some kind of ln of x, yes, do that substitution. You put u equal to ln of x. Otherwise we cannot solve such integrals. So I put u equal to ln of x. I differentiate this, I get du is dx over x. You see? We have dx over x in here, and we have dx over x in here. That combination is gone, right? In terms of u. So I will find antiderivative of this function without 1 and e, without integration limits. So I write, ln of x dx is equal to, since ln is equal to u, I write u in here, dx over x just du, so I have u du. And that is very simple, which is 1/2 u squared plus c, right? Or I write 1/2 ln of x squared plus c. And now I just need to plug 1 and e into this formula. And I get the integral is equal to 1/2 ln of e squared minus ln of 1 squared. Ln of e is just 1. Ln of 1 is 0. So you have 1/2 1 squared minus 0 squared, which is 1/2. Okay. Let's move to the next one. Find the area of the region bounded by the graphs of the equations. Okay, so in this problem, you don't see any graph. So we have to make the graph for ourselves. But I don't ask you to do, an exact graph of this function, because we don't need that, The only thing we need in this is we need to make sure if the graph is above or under x-axis, or we have a mixed one. A mixed one means like this. So in this situation, we have to break integrals, into A, B, C, right? Because here you have a negative area and here you have positive area. We just cannot evaluate integral from A to C to get the area of our region. So we have to make sure about the graph first. You see, here we have x from 3 and to 6, right? That means, x from 3 to 6, for such x cubed minus 2 is always greater than 0. You see that? So we write here, for, let's say, on integral 3 to 6, x cubed minus 2 always greater than 0. Then the function y equal to fx is greater than 0 on this interval. Done. Because on the top you have, 9x squared. So that means the area is just, definite integral from 3 to 6. 9x squared dx over x cubed minus 2. So we solved very similar problem just some minutes ago. Because you see, in here you have x cubed minus 2, and in here you have x squared dx, right? So I just tell you, please do substitution, u equal to x cubed minus 2. Then you solve du equal to 3x squared dx, okay? And then I hope that you can solve this problem yourself. In the next problem, solve for x accurate to 3 decimal places. This is a pre-calculus problem. I just put in here so that you can practice more with ln functions. Let's say we on the left hand side, ln of x plus. So we group them together. So you have ln of x times x minus 7 equal to 0, and then from here you get x minus 7 equal to e to 0, which is 1, right? And then from here you get x squared minus 7x equal to 1, or x squared minus 7x minus 1 equal to 0. This is nothing but the quadratic equation, right? I will not solve this problem for you, but I will remind the quadratic formula. That is x1 to equal to negative b plus minus b squared minus 4ac over 2a. So please apply this formula for this equation to get what you need. All right, move to the next one. Find the derivative of the function. Yeah, we have a lot of problems with differentiations, but it's fine. It's good practice. So again, the inside function is complicated, right? So I can write like ex ln ex in here, because ex on the top with positive side. 1 plus ex in the bottom, I have minus ln of 1 plus ex. So now you can differentiate, but before that I want to simplify one more thing. Ln ex is just x, right? And here ln of 1 plus ex. Okay, don't write this guy is not ln of 1 plus ln of ex. No, they are different. Okay, don't do that. So now I can differentiate. I get 1 minus again here's 1 plus ex derivative, which is u prime over u 1 plus ex, then 1 minus, on the top I have ex, in the bottom I have 1 plus ex. If I cross multiply and simplify, I will get 1 plus ex, and then 1 plus ex minus ex, which is just 1 over 1 plus ex. That is the final answer. All right, so let's move to the last page. And here, again, find the derivative of the function. Another application of ln function, okay? So for such problem, we have, let me zoom that down, right? So we have this function like x to 9x plus 1, guy of exponential, right? Guy of power. So we don't like 9x plus 1 on the top. We have to apply ln of x or logarithmic function with any base, right? To remove this from the top. So if I apply ln of y, I get ln of y equal to ln of x, 9x plus 1, right? 9x plus 1. So what is that? That is 9x plus 1 times ln of x. You see? ln of y. So now if we differentiate both sides, kind of implicit differentiation. Let me differentiate both sides. I get ln of x, ln of y in here, derivative equal to 9x plus 1, ln of x derivative, right? On the left hand side, this guy is just equal to y prime over y, right? On the right hand side, we use the product rule. I get derivative of 9x plus 1 is 9, ln of x. The second one is 9x plus 1, ln of x prime is just 1 over x. And then I get y prime equal to y multiplied with 9 ln of x, and then plus 9x plus 1 over x. And of course you just plug y in here, so you get the final answer. That is another application of log functions. Evaluate the limit using Lobster rule. Okay, this is another one. And for this problem, when you plug 1 into this function, you get 0 over 0, right? Yeah, we can use Lobster rule. Usually when you get 0 over 0, that means 1 is common 0. Since 1 is common 0, you can factor that out, okay? But in this case, you don't need. You can do directly using Lobster rule. So you can find, limit of derivative of the top, x27 minus 1 derivative, and then in here, x29 minus 1 derivative, right? X goes to 1. And then limit on the top, you get 27, x to 26. In here, you get 9, x to 8, right? X goes to 1. And you plug 1 into this, you get exactly 27 over 9, which is equal to 3. So since this limit exists, right, and equal to 3, by the Lobster rule, the original limit exists and equal to 3. Is it? It's pretty simple. Okay, the last problem is also about Lobster rule. So I will give you a hint how to solve this. How about that? But before that, I mean, let's do some analyze. Cosine pi over 2 minus x is just sine x, right? So your limit is nothing but the limit of sine x to the x goes to 0 from the right. And this limit has the form. When you plug 0 into this limit, into this function, you get 0 to 0. You know, and we solve one problem like that in this video. So for such limit, I put a equal to this guy, right, and apply ln. From here I get ln of a is equal to limit of, okay, go to this, and then ln of sine of x to the x. Since ln of power, we can bring the power down, right? Have limits x to 0, and then here I get x ln of sine x. So this limit has the form 0 times infinity. Okay, let's say negative infinity in here, right? Because sine x goes to 0, ln goes to negative infinity. For such one, we have two ways to solve that. We can change to the form 0 over 0 or infinity over infinity and use Lobster rule. And each time when you see ln of x, right, try to keep ln on the top, because when you apply the Lobster rule, you have to differentiate. So you need to keep ln on the top. It will be easier for you to differentiate. So I will write this limit in the following form. I have ln of sine x over, let's say, x to negative 1. How about that? It's 1 over x, or x to negative 1. And we had the form infinity over infinity. Oh, sorry. Okay, now let's differentiate. Let's find the limit of derivatives, right? Let's find the limit of derivative. I have limit of, what happened? I have limit of ln sine x derivative over x to negative 1 derivative. X goes to 0. So on the top I have cosine x over sine x. In the bottom I have, negative x to negative 2. X goes to 0. So times divide by x to negative 2 means multiply by x squared, right? So I will rewrite that is limit of cosine x times x squared over sine x, and the negative here, I just bring to here, right? So I get negative in here when x goes to 0. And we know that at 0, sine x is similar to x. I mean, we can replace sine with the x, right? So this limit equal to negative limit cosine x times x squared over x. X goes to 0, and then that is just limit x cosine x with the negative in here. X goes to 0 from the right, and that is just 0 times cosine 0, which is 0. So finally we found that ln of a, this guy is equal to 0, and we write ln of a is 0. From here you get a equal to e to 0, which is 1. So this is all about the practice test. And of course, don't worry that too much, because on actual test you will have about 10 to 12 problems. Okay, so I hope that this video is useful for you to prepare to a test. Thank you for watching.